Your presentation?
Yeah, that's mine. Hello, everyone. Actually, I would like to appreciate the Remotech for giving this opportunity to discuss today about the better remediation strategy for remediation of Kuwaiti oil contaminated soil. Before everything, I would like to introduce myself. My name is Meshari almutairi. Actually, I studied in Portsmouth for 2 years ago. My focus at that time, the topic of my thesis was remediation strategy for the oil contaminated soil. Today, I will talk about sad story. Really, in fact, it's a sad story, which is the Kuwaiti oil leak. Actually, Kuwait environment suffered significant damage resulting from the Iraq invasion in 1990. The result of this destruction, huge quantities of crude of oil leak had been created, which caused a threat to the human and to the ecological system. If you see here, we have around like 49 kilometers square, which is the whole area of the contaminated soil, and we have around 22 million meter cube of the whole area for the oil contaminated soil. Unfortunately, all this contamination had been left like for 25 years. Therefore, we cannot see any more like oil contaminated soil because all the characterization of the oil had been changed and become a withered oil contaminated soil. In this case, all the traditional method cannot be achieved the target. I mean the target to remove the contamination or reduce the contamination. If you see this figure, that's one of the oil leak which exists right now. If you see the top layer, we call it the oil sludge, and then we have the oil contaminated soil. Actually, the average depth for the oil contaminated soil is different from area to area. The range is 2 meters and reaches until 6 meters. We have the evaluation of the oil leak. We have around 172 oil leaks, which is actually in the top of the groundwater. Before 25 years, when Iraq destroyed around 700 oil wells, the people at that time, they used the seawater to extinguish all the oil wells, which caused another problem, because all the salinity, okay, which came from the seawater, it goes to the groundwater. Now our groundwater is affected as well because of this disaster with high salinity and the TPH as well. And we have around 71 oil leak, which is near from the gathering center and near from the residential area. Actually, in 1993, Kuwaiti government decided to do some studies for the soil remediation, and there is 3 different types of remediation at that time. They used the land farming and windrow and biopiles. They mentioned that they achieved some of the results, and the reason for this test, just to prove to the United Nations that we have a problem which created by other countries, so please, we really need to solve this problem. Recently, we received 3 billion from the United Nations to solve this problem. Before 5 years ago, 3 companies as well, they came and they tried to solve this problem with the traditional method. But they did not consider that they are not dealing with any crude oil anymore, because it's changed. Now, when I mean it's change, you need a new method, a new development method to treat this disaster. What I mean, because all of the people try to use only the bioremediation, and some of them try to use also kind of soil washing. When I spent 80, let's say 5 years, and when I mentioned 8 years, I calculate my master's degree as well. Actually, I stayed in Portsmouth 5 years. At that time, trying to find the best solution to solve this problem. Actually, to solve this problem, I mean either remove or reduce the contamination. Actually, I started to do some evaluation about all different kinds of treatment which is visible and available in the market. I mean, for the bioremediation and the thermal and the physical process. At the end of the day, I decided to use the soil washing. But when I'm going to say the soil washing, we have a couple of things of the soil washing. There is like more than 115, if I'm not mistaken, different kinds of soil washing. So, before I jump to the soil washing, I started like the other people, like the other companies, with the bioremediation. I found that the bioremediation, it's really in front of hard job, you know, to carry on the process. Then I decided the soil washing, I started with a lab scale. After 2 years, I found another method, okay, for the soil washing. Now, this method, it's begun or become patent, okay, under my name. I'm using a new technology for the soil washing. I'm using only water to remove this contamination. No any chemical, no solvent. Actually, there is theory, like dissolve like. When I'm saying like dissolve like, polar dissolve in polar, and non-polar dissolves in non-polar as well. You know the water has polarity. The water has negative and positive charge. The only thing that I'm doing, I'm increasing the negative charge. So when you are increasing the negative charge to the water, what's going to be happening? Repulsive force. Repulsive force between all the molecular compound which is exist in the soil. So when I'm increasing the repulsive force, all the contamination will be removed easily from the sand. Especially you are talking about not volatile or semi-volatile. You are talking about asphaltene. You are talking about something, a weather contamination, which is not easy to remove. Especially these days, they use some kind of extraction with solvent. But thanks God that the water delivered the job. It makes sense. When you wash something, you will have a residue. And my residue, which is oily wastewater. When I done my PhD, I went to the KNDC and the KOC. These two companies, they are in charge in my country regarding for the soil remediation. Among 72 companies came try to treat this contamination. I had taken all the risk. I did everything for free to prove the efficiency of this method. Actually, I agree with them. When you are trying to bring something new in the market, no one can believe, especially you don't have any references in the back. And that's the sweetie part of the invention. Actually, I signed 2 MOU, Memorandum of Understanding, with KOC and KNDC. 3 different samples they brought it for me. They brought the high contamination, and the medium contamination, and the low contamination as well. Within 2 hours only, just go to this side, within 2 hours only, I removed all the contamination. The process is very simple. The beginning, I'm doing only sieving analysis, you know, because it's this district was a war of district. So we're expecting some mine, we're expecting some, you know, I'm gonna be honest. I remember in one time when you see, I found some military shoes, you know, with it. It's come with the sand, you know. Therefore, I should do like some sieving in the beginning, you know. And after that, we pump the soil to the sand washing system. We left it for like 1 to 2.5 hours. Okay, after that, the sand is shifted to the sand separator system to take out the sand, and the water we send it to the normal treatment, which is the flocculation with the coagulation. Within 2 hours, the water can be recycled, and we separated the oil. It's not oil, sorry, withered oil. Actually, the chemistry of this machine, when I started before 1 year, it was 500 kilograms with, and 500 liters, not 200, sorry, with 500 liters. The ratio was 1 to 1. But today, I scale up the machine, and the machine able to wash 3 tons per hour. And I'm planning, at the end of this year, to fabricate 25 tons per 2 hours as well. That's the contamination. As I explained previously, the high was around 80,000 to 8,000. We reduced the contamination to below 1,000 milligrams per liter. But the research did not stop. I carry on with my research, because all the people, they are interested regarding for the bioremediation. So if I'm using the bioremediation with type of contamination and this much of toxicity, it's something combustible. So when I'm reducing the contamination, I used new technology, which is the earthworms. You know the earthworms, we call it a bioremediation. I use the earthworms to see the capabilities of the earthworms. Are they able to survive with high contamination, or if they are able to survive with the low contamination and can do some degradation as well? 4 experiments had been done. If you see here, with after several days, like for 5, 7, 10, 15 days, with different concentration, below 0.5%, below 1, 1.5, and 2% of the oil contamination, I used 2 different kinds of earthworms. One of them we called Kitida and Tristis. These 2 earthworms, they are popular for degradation. The interesting part, I found that for Kitida, when the contamination is below 0.5%, it's able to survive, even after 15 days. That means, which is delivered to us a message, if we are using like a soil washing and the contamination is reduced, there's no need, for example, to re-wash it again if you want, because based on the limitation, if the contamination is below 1%, you should send it to the landfill. But in our country now, it's safe. But I'm hoping the rule will be changed in the future, because really we are suffering from this contamination. From the benzene, especially the thing in the hydrocarbon, we have 2,000 people that are suffering every year from the cancer. And we know the source of this contamination. That's why I put in my mind the contamination should be reduced more. So I use the earthworms for several concentration of contamination. For 0.5, 1, 1.52. I found that the earthworms, if the contamination below 1, yes, they can do the job. They can survive. So that means they have the capabilities to do some biodegradation. But if the contamination above of that, 1.5, which means more than 2,000 ppm, no, it's very difficult for earthworms or the microorganism, to do some digestion. Finally, I got an approval from the KNDC and the KOC regarding for the soil remediation projects. Now my technology or my machine, it's approved in both companies. And we got a Golden Award project in 2016 for the best practical project, because we are friend of environment, no any chemical, nothing except of water. The commercial parts. The process, as I showed you, is very simple because there is no chemical, no thermal. The pilot, when we had done the 500 kilogram, it was a promising technology. When I spent more money to fabricate for the 3 ton, I'm gonna be honest, I was scared. What I'm doing, maybe I'm just throw away my money. But thanks God, I achieved better result than the first one. And the good things, we achieve the Kiba and it's zero waste. Because the oil which separated from the sand, we use it as a fuel cake, okay, for another process. That's my conclusion, which is cost effective and the process works better with fine soil particles. And this one is very important point, because for the soil washing, it's very easy to wash something which has more size of aggregate. But the problem, if you are dealing with the silt, or if you are dealing with something small, fine, particle, because it can pass through the machine. But with my machine, no. And I'm going to explain the secret, because there's no secret, it's published now in patent. You can show it, you can go back, see. I'm using water with solidification with mechanical stirrer. It's a very simple process. The concept of this process, I would like to raise up the sand and make it suspension inside the tank. Once it becomes suspension, it's make it easy for the cavitations to attack to the sand particles. But during this process, the negative charge is increased. Therefore, you have three different attacks. The negative charge is attack from sand, and the cavitation, it's allowed the negative charge by increasing the contact angle between the oil and the sand. Thank you so much for your great attention, and I'm waiting your good question.
Thank you. Thank you for this impressive presentation. Any questions?
You say no thermal treatment. What was the temperature when you were doing this pilot test?
It's normal temperature.
What is it? I mean, you're in the middle of the desert, right?
Yes.
So what is it, 40 degrees, 35?
Actually, it doesn't make difference, because the soil has been excavated before and they shed the sand for us. Okay, it's XT process. The water temperature was the normal water temperature. Okay, because we pump it from the groundwater. It's around like 20 Celsius, something in this range. Yeah. Please.
What is the target concentration?
Yes.
And what is the % removal you achieve?
I'm not quite sure if you can see this one clearly. It's 91% the removal. And yes, please go if you would like to see it again. I don't know if it's clear enough. It's 91%. Actually, they asked me to reduce the contamination below 10,000.
3,000.
10,000 ppm. I reduced it below 1,000. So much difference. So please.
Other question?
Cheers.
It's almost coffee time, so it's always a problem when you want to start a new discussion. But I have maybe